We're asked to find the derivative using the limit definition of the derivative shown here on the right, where f prime of x is equal to the limit of the difference quotient as h approaches 0. So in our case, f prime of x is equal to the limit as h approaches 0, again of the difference quotient, where f of the quantity x plus h is 3 times the quantity x plus h plus 7, all divided by the quantity x plus h plus 6. Then we have minus f of x, which is minus the quantity 3x plus 7 divided by the quantity x plus 6, all divided by h. Notice if we try to perform direct substitution, we would have division by 0, and therefore we'll have to perform algebra on the function so that we can then determine the limit. Because we have a complex fraction, we will now multiply the top and bottom of the complex fraction by the least common denominator of the numerator, which we can see is going to be the product of the quantity x plus h plus 6 and x plus 6. Let's show the algebra below. Starting with the difference quotient, again we will multiply the top and bottom of the complex fraction by the product of the quantity x plus h plus 6 and x plus 6. On the top, it might be helpful to write the product as a fraction with the denominator of 1. So multiplying in the numerator, notice how for the first product, the quantity x plus h plus 6 will simplify out, leaving us with 3 times the quantity x plus h plus 7 times the quantity x plus 6. And then we have minus, for the second product, x plus 6 simplifies out, leaving us with the product of 3x plus 7 and the quantity x plus h plus 6. In the denominator, we have h times, again, the product of the quantity x plus h plus 6 and x plus 6. And now we need to begin simplifying the numerator. Let's distribute the x plus 6, which gives us 3 times the quantity x plus h times the quantity x plus 6, and then plus 7 times the quantity x plus 6. And then for the second product, we will distribute the quantity 3x plus 7, giving us minus the product of 3x plus 7 and x plus h minus the product of 3x plus 7 and 6, all over the same denominator. Let's go ahead and find the product of x plus h and x plus 6, which will give us x squared plus 6x plus hx plus 6h. And now we will distribute 3, which gives us 3x squared plus 18x plus 3hx plus 18h. Distributing 7, we have plus 7x plus 42. Next, we subtract the product of 3x plus 7 and x plus h, which gives us minus 3x squared minus 3hx minus 7x, and then minus 7h. Then distributing 6 and subtracting, we have minus 18x minus 42. We need to be careful on the second part because we are subtracting the products. All this is still over the same denominator. And now we simplify the numerator. We have 3x squared minus 3x squared, 18x minus 18x, 3hx minus 3hx, 7x minus 7x, as well as 42 minus 42. Notice now we're left with 18h minus 7h, which is 11h, over the same denominator, which is h times the quantity x plus h plus 6 times the quantity x plus 6. Notice how now there's a common factor of h between the numerator and denominator that we can simplify out. H divided by h simplifies to 1. Notice now we just have 11 divided by the product of the quantity x plus h plus 6 and the quantity x plus 6, which means the original limit is equal to the limit of 11 divided by the product of the quantity x plus h plus 6 and x plus 6 as h approaches 0. We'll notice in this form, we can perform direct substitution the limit is equal to 11 divided by, well, if h is going to 0, we just have the quantity x plus 6 times the quantity x plus 6, which gives us the square of the quantity x plus 6. So now we know, using the limit definition of the derivative, f prime of x is equal to 11 divided by the square of the quantity x plus 6. I hope you found this helpful.